Welcome to the demonstration of Frankenstein framework. Frankenstein is a framework that combines state-of-the-art question answering component in a single platform to promote reusability and build question answering systems in collaborative effort. To start the Frankenstein, the first step is to start the StarDoc triple store, because for each question, answer and all the associated data related to the question, Frankenstein store it in a named graph and create a knowledge graph for each question. Why we create the knowledge graph? Because for each question, when we create an individual knowledge graph, the analysis of the data which is produced in question answering process is easy. Now on the screen you can see a list of all the Frankenstein components, but we start couple of them to show you the demonstration. So we have just started the question answering pipeline of the Frankenstein, because all the components in Frankenstein are integrated in the pipeline as a RESTful web service. So all these components are independent and you have to start it by running its jar file. We have just started the tag.me disambiguation component and you can see it on the screen. Now we have started the second component, which is babelfy NED, that is also a disambiguation component which disambiguate the entities present in the question and link it to its DBpedia knowledge graph mentions. Now we demonstrate you the functionality of Frankenstein. Before that, we show you how question answering works on Google. We have just typed a question, name the municipality of Roberto Clemente Bridge, and now we see what Google has returned. Google has not returned a concrete answer, but Google gives you a complete list of different URIs and it does not contain a right answer. Now we use the same exemplary question to demonstrate you the functionalities of Frankenstein. Now we type this question on user interface. We choose a component which is tag.me. This component expected to identify Roberto Clemente Bridge as an entity and provide you the DBpedia URL of this. Now the question answering process is executing. On the screen you see a URI of a named graph. As I said earlier, Frankenstein store all the data in a named graph, and now we're logging into StarDoc to see what data has been stored for the particular question in the particular named graph. Now we query this named graph to see what data has been stored when we executed tag.me name entity disambiguation. Now we execute the query and see the results. All the results are annotated in the question answering vocabulary, because all the data which has been stored in StarDoc for all the components has been first wrapped in a question answering vocabulary, and this vocabulary provides a homogeneous representation of all the data which has been generated in question answering process for any question for any component. Now on the screen you can see the output produced by tag.me disambiguation component, and tag.me has successfully disambiguated Roberto Clemente Bridge and provided you the DBpedia URL, which you can see on the screen. And you can also see at which time tag.me has annotated it and who has annotated it. In this case, tag.me is the right answer. Now we show the similar functionality for another disambiguation component, which is babelfy disambiguation component. We execute the question answering process to see what this component returns as an answer. Now we again see what is the output of babelfy disambiguation component by querying the newly formed named graph for this question for tag.me. And this is the advantage in Frankenstein, that for each question a separate named graph is produced. So the data analysis task becomes very easy, that at which point the component is failing or which component is good for which type of question and so on. Now on the screen you see the output produced by the babelfy disambiguation component. So besides the right answer, which is Roberto Clemente Bridge DBpedia URL, it also gives you municipality DBpedia URL. It also gives you Roberto Clemente as a DBpedia URL. Also, of course, the right answer Roberto Clemente Bridge is also present in the one of the answer, and the last answer produced by Babelfy is Clemente bridge. So rather than giving a precision of 0.1.0, Babelfy gives you the precision of 0.25. So by showing this demonstration, we have just illustrated that using the Frankenstein, you can actually see which component is failing at which point. Now we run two components to see how they have performed. We have just started Stanford recognition task component and also an existing named entity disambiguation component, which is which also have the same functionality to disambiguate the DBpedia URL of the entity. And on the screen, you can see Roberto Clemente bridge has been produced, and 25 and 48, which you see on the screen, is the spotted position of the entities by Stanford name entity recognition. So two components can also be run in Frankenstein question answering framework, not only the complete question answering pipeline. Now we run a complete question answering pipeline which consists of a disambiguation component, a relation linking component, and a query builder component to see what actually is the answer of this question in using the components present in Frankenstein. We again try to query the name entity recognition components output, relation extraction output, and the query builder output by seeing the name graph of the particular question. Now we go on the final output, and on the screen you see Roberto Clemente has been produced by TagMe, municipality has been produced by the disambiguation property component, and finally the Sparkle query has been created for this question by the last component, which is the query builder. So when we have run the complete question answering pipeline using three components, this Sparkle query has been created, and the answer we have shown, which is like Pittsburgh, Pennsylvania. That means for the question, name the municipality of Roberto Clemente bridge, our system says the answer is Pittsburgh, Pennsylvania. Now we execute the produced Sparkle query on the endpoint of DBpedia, and now you can see the output of our answer and the DBpedia output matches. Hence, Frankenstein is a flexible framework to create question answering systems just by configuration, and you can also compare the output. On the screen, now you can see the output of the classifier or the prediction mechanism which Frankenstein has. So we have trained a classifier using 3000 questions, and each question is represented in a feature set comprised of post text, question length, and answer type. We have used these features from question classification research done in information retrieval domain. We then perform cross-validation to check the validity of our prediction mechanism in Frankenstein. We predicted F-score of each component for a given input question and chosen the best component. On the screen, you can see each task, total number of answerable questions, and classifier values, which means for how many questions our prediction mechanism has predicted the correct values. For detailed results of prediction values, you can see our recent work accepted in World Wide Web Conference 2018 in the research track. Thank you so much.